सर तुम्हाला होस्ट केलंय. सर तुम्हाला होस्ट केलंय.
Okay, just
तुम्ही
a-
2 ठिकाणाहून लॉग्ड इन आहात.
हो हो आता काय माझं दुसऱ्याचं ते लॅपटॉप वरून ते झालंच नाही मी आता
कुठल्या कशावर होस्ट करू मग मी?
मला आता लॅपटॉपवर म्हणजे धनंजय कंटे मी त्याचा व्हिडिओवर आहे ना
सर तुमचा इको इको येतोय. 2 ह्याच्यावरून लॉग्ड इन आहे तुम्ही.
एक बंद केला धनंजय कंदेवर
तिकडे होस्ट केलं होतं मी. ठीक आहे, मग तुम्हाला इकडे आता तुम्हालाच होस्ट करायला लागेल परत. एकावरून दुसरीकडे. तुम्ही होस्ट आहे ऑलरेडी.
ओके करतो. ठीक आहे आता मी आय विल हॅलो
Yes, sir. Good afternoon.
गुड आफ्टरनून या हां सॉरी जस्ट अस्मिता has joined. So I will start recording.
सर रेकॉर्डिंग ऑलरेडी स्टार्ट केलंय.
ओके ओके एको येतोय का अजून?
नाही आता इको येत नाहीये. फक्त ओके सर. तुम्ही होस्ट आहात, सो यू कॅन कंटिन्यू. मी लॉग आउट करते.
ओके
ओके, थँक्यू.
सो I will share PPT. I'll share PPT. Okay.
Yes, sir. You can start.
तुम्हाला एको येतोय का?
नाही.
मला येतोय काय प्रॉब्लेम आहे कळत नाही. एनिवे I will start.
Yes, sir.
So good afternoon.
Good afternoon, sir.
So welcome to today's lecture on performing financial analysis. Okay, so this lecture is related to financing. Okay, so I think I don't think any other persons will join. So we will start the lecture. Okay.
Yes, sir.
Yes, sir.
Okay. So this lecture actually is a continuation of our lecture that we had on chapter 10, book 1, which was the heading was financial, you know, this financial analysis management, which covered most of the basics of financing for energy efficiency projects. So we had all the all the terms also we had also reviewed. Just for your understanding, I'm just reviewing what we had covered there. So it was basically the financial analysis techniques or the financial analysis which we covered, and under that we studied a payback period. We also studied a return on investment ROI. We studied what is NPV, that net present value. We also studied what is IRR or internal rate of return. So these were the basics which we started. We also saw what is cash flow, positive cash flow, negative cash flow, what is meant by salvage analysis. Okay, we also saw what is meant by salvage analysis, and also we saw what is the sensitivity analysis or the risk analysis. Okay, in investments for energy efficiency project. We also saw what are the financing options for financing the energy efficiency projects. This mainly the debt financing, equity financing, retained earnings, capital lease, true lease, and performance contracting. We also talked about the role of ESCOs or energy service companies as a part of our assignment. Okay, or part of our study of that particular lecture. So these were all. So most of the things will be, we are all now familiar with that. We will be proceeding further with this chapter, which is chapter 10 of book 10. The title of the chapter is Financial uh, Performing Financial Analysis. That is a chapter that you can see on the screen. And here also what we are going to study is simple payback period, return on investment, net present value, internal rate of return, sensitivity analysis. These are the topics. We are not going to talk more details in that. But what we are really going to cover here is the all other aspects of financial management. Okay. So really speaking, here again, the chapter heading is slightly misleading because in this book 4 we are supposed to be addressing the performance assessment or the management, whereas they are saying performing financial analysis. So really, this is a slightly misnomer for the chapter. But well, since we have already studied the financial techniques, now what we are going to study is that we are going to uh, study all these financial aspects in detail. So what we will be studying is in this particular chapter. This is what I am mentioned to you. Just hold on for a minute. Give me 1 minute. Just give me just 1 second, because there is some problem with my other laptop, which I continue to have as a backup. So there was some issue. There is some issue. I will just open it there, and then I will again just hold on for a minute. Okay. Sorry for interruption, but let me have the standby ready, so that just as there was again some error occurred. I think once we experience it, I think so. Once that particular thing is on. Okay, let me continue with this. So what is important in this performing financial analysis is that first we must know what are the what meant by energy efficiency projects and how to finance it and how to perform the financial analysis of it. Okay, so we are this is what we are going to study. If while planning an energy efficiency projects, we had to first management will ask or anyone will ask what is the total investment? Okay, what is the cost? And what is going to be the profit? What is the benefit that we get? Okay, so now I'm with it. The other my PC is also on. I will continue. So anybody will be asking the question: what is the proposal cost and what is the profitability? What are the return? And obviously, these are the good questions which will have to be answered satisfactorily before the management takes up any decision to investment. Okay, because no management is going to invest unless they are clear about the total cost that is involved in the or total investment that is involved, and also what are going to be the returns or the profits which the company is going to get. Furthermore, there are many such areas where management is will be financing for in their organization, and various financial requirements have to be met. So they will try to first find out which is the better investment. That means where we are going to get more profit, where the returns are going to be more and also faster. So that is what we must analyze, and that's what the energy managers or energy managers, it is their job to evaluate the financial analysis and convince the management how much is the profit, where is the how much is the payback period, or in how much period the money is going to return. So any issues is associated with the financial management, financial analysis regarding the capital assessment may have to be answered. Okay, so let us try to again understand some of the terms better, because now we are now looking at the issue from the point of view of actually taking up the management or actually investing in uh, uh, in the uh, in the organization. So first thing is that fixed and variable cost. I think most of us, working in the industries, I think participants, they will be knowing where we are involved in the cost assessment and fixed and available cost. So what is fixed cost is the total investment required, including its equipment cost, including its structure cost, foundation cost, and whatever it is. So each and every element of the investment required for that particular making that energy efficient project working, that is the fixed cost. And in order to operate that, to get the savings, we have to incur the cost. For example, we may have to provide electricity, we may have to provide the utilities, we have to, of course, provide the manpower, and there will be repair and maintenance costs. So these are the variable costs because they will vary with the type of production and type of working. Okay. And the my inputs, all other inputs required. So let us try to say, to make it more clear, I will, this here is an example which is given over here. I will go through that. Okay. So the example 10.1 is that the DG set is to be installed, and it has got capital cost of 9 lakhs rupees, which by installing which we will be providing the power. It is mentioned that the annual output from the DG set, that is the power supplied by DG set, is 219 megawatt hours. Okay, in a year, the maintenance cost is rupees 30,000 per annum, and the cost of the producing that each unit of electricity per kWh of DG set is rupees 3 rupees 50 paise. This is the data given, and what we need to find out over a period 5-year period, what is the fixed cost and what is the variable cost. So the example is very simple. The capital cost of the generator, as you can see the table, this is the fixed cost, is the capital cost, which is rupees 9 lakhs rupees, whereas the annual maintenance cost, which is given here, is 30,000 rupees per annum for the next 5 years. It is 30 into 5 is 1,50,000 rupees, and the fuel that will be consumed for producing this 219 MWH, it has to be calculated like this. We have to calculate backwards because we don't know what is the loading on the DG set. If we knew the loading in kilowatt multiplied by the hours, we could have calculated the variable kWh and the cost. So therefore, what is given here is 219 is the megawatt hour generated. We know that the cost of each unit is 303 rupees 50 paise, and total time period is 5 years. That means the total cost is 2,19,000. That is MWH, and rate is 350 in M1 and 5 rupee 5 years. So it is 38 lakhs 32,500. That means the total cost is 9 lakhs plus 38,000 to 3250. That is 48,000, 82,000. Obviously, this is the total cost, out of which 9 lakhs is the fixed cost, and the variable cost is 38 lakhs 52,000 plus 1 lakh 50,000, which is equal to 39 lakhs and 82,500. Okay, so this fixed cost is 9 lakhs rupees is if you work out the percentage, it is 21.5% of the total cost, whereas the variable cost, which is 39 lakhs 82,000 rupees to 50, that becomes the the fixed cost. Okay. Now, so if we work out the 2,19,000 and working hours, you consider, assuming that it is continuously working, the total load works out to 50 kilowatt. Okay. Now, if the loading on the generator is increased to 70 kilowatt, or its output is increased to 70 kilowatt, then the cost is going to increase. Fuel cost is going to increase to 90 kilowatt into so many hours into rupees 350 is it rate plus 5 years. So if you just take a proportionate one, that means in the total fuel cost, if you work out, it will be 53 lakh 65,000. I think this is what we can very easily calculate. And at that time, at that cost, fixed cost remains the same. So 9 lakhs fixed cost as a percentage of 53 lakh 65,000 becomes 16.37%. So one thing is, as the loading of the generator or the output of the generator increases, the total fixed cost percentage is going to reduce, and total variable cost is going to increase. I am sure that this concept is very clear to all of us. Okay. Is it clear?
Sir. Yes, sir. Clear, sir.
Okay. Now let us go to another example. Okay, to understand this is regarding the cost. A electricity is bought from the utility, suppose it is at the rate of rupees 4 rupees 50 paise per kilowatt hour. Then we have to find out what will be the break-even point for the generator. Now, what do you mean by break-even point? The cost of generation, from DG set of a particular kWh becomes the same as the cost variable and fixed cost of the generator. Okay, so which means we equate the two for the utilities. Now we know that 50 kilowatt is when the output is 50 kilowatt, and the N we have to which we have to calculate is the total how many hours DG is to be generated. Okay, and the rate of generated unit or DG unit is 4 rupees 50 paise. So the cost of generation becomes 50 kilowatt into 4.5, sorry, into n number of hours, n we have to calculate, into 4.5 is the total cost of DG set generated units, whereas in any year, of course, and now lakhs is the fixed cost, and 1,50,000 is the is the cost of electricity bought. Okay, that is the data given is utility cost is calculated. So if that is 1,50,000, that is the 1,50,000 is the operating cost. Okay, 30,000 per year plus 9 lakhs is the DG cost, plus 3.5 lakhs is the rate of electricity, plus 50 kilowatt it has uh, is a kilowatt into number of hours. Okay, so if we equate these two, that means the utility cost, utility expenses versus the DG set generated cost, the N which works out to 21,000. Okay, that means if the DG set is run for 21,000 hours, it becomes break even. So if it is run more than 21,000 hours, the DG set cost becomes lower. That is what it means. If the output, as we have mentioned in the earlier example, is 70 kilowatt, if for the 70 kilowatt, if we do the same exercise, we find that the number of hours is 15,000. That means break even is 15,000 hours. That means the break even point is lower when the loading is more. That means if you generate more kilowatt, generate more units from the DG, it becomes cheaper earlier with 15,000 hours instead of for 70 kilowatt loading, instead of 21,000 hours for loading of 50 kilowatt. So that is a very simple calculation to calculate the break-even. So many times the question will be asked to the energy manager that we have installed an DG. So what is its break-even point? How many hours we should run? If we run for less number of periods, okay, then the cost of DG generators will be higher. Okay, in that case, it is cheaper to use electricity up to rather than using the DG set. So economics is governed like this. So therefore, the usage of DG set, number of operating hours, can be decided on the basis of such calculation. Then we go to interest charge. Now, interest charge, you all of us understand the interest charge. There is a simple interest and there is a compound interest. I think we did study it earlier also, but we know that simple interest means, if interest rate is 10%. Now, if you say deposit 1,000 rupees, after 1 year, we are going to get 1,100 rupees. After 2 years, again in the second year, we are going to get 100 rupees. Okay, so every year the interest that we get is 100. So also, if we take a loan, the interest that we have to pay is the interest rate remains the same. So you will pay the same interest in every year. However, the concept of compound interest is that when we spend 1 lakh rupees in first year, and we have to also pay 10% interest, that means what we are paying is 1,10,000 rupees at the end of first year. Okay. In the second year, we have to pay interest I mean, assuming that we are not paid in the first year, we have to pay interest of 10% on 1,10,000 rupees. That means it becomes 1 lakh 10% one on 1,10,000 rupees. So it becomes 1,21,000. So the interest goes on increasing, interest component goes on increasing. That is what it is. Now let us try to understand another concept which is again very easy. There is an example given 10.3 which says that a company borrows 3 lakhs rupees to finance a boiler, new boiler installation. The interest that the company has to pay is 10% per annum, and it has to be paid back or repaid in 5 years. So what example says that you calculate total repayment that is done, and the monthly repayment value, assuming a simple interest and compound. That means what we are trying to understand is how simple interest concept and compound interest concepts are implemented or worked out. Okay. So first of all, let us calculate the simple interest, which is very simple. Total repayment will be 30 lakhs rupees is the total, 3 lakhs rupees. No, it is not 3 lakhs rupees, I am sorry. It is 3 crore rupees. Okay, so 3 crore rupees is the cost of the financing boiler. 10% interest means that actually the interest payment becomes 10% of 3 crores, that is 30 lakhs rupees. Okay, and plus it is 10% of 30. I think there is some mistake in this. Okay, let me read it again. So actually the company borrows 30 lakhs rupees to finance a boiler. Okay. So the total, he has to pay 30 lakhs rupees anyway. Okay. So assuming that he pays after 1 year, in 1 year he has to pay an interest of 10% on 30 lakhs after 5 years. Sorry. In 5 years he has to pay first the fixed cost, that is 30 lakhs rupees, plus interest at the rate of 10% on 30 lakhs. That is equal to 3 lakhs per year for 5 years. So the total interest component becomes 15 lakhs, and add to that 30 lakhs rupees is the fixed cost. Total is therefore 45 lakhs. Okay. So the total repayment is 45 lakhs. And monthly repayment will be will be 45 lakhs multiplied by divided by, because 45 lakhs is the total repayment. 5 years, that means 9 lakhs rupees per year divided by 12 months. So therefore monthly payment is 45 lakhs by 12 multiplied by 5 is equal to 75,000. Then now let us go to calculation of compound interest. Now repayment at the end of first year will be 30 lakhs rupees will be, say, are payable, and first year interest is 10%, that is 10%. Now 30 lakhs rupees is 3 lakhs rupees. So total repayment becomes due is 33 lakhs. If you don't pay 33 lakhs rupees after 1 year, you have to pay 10% on 33 lakhs. That means the total repayment in that year will be 33 lakhs plus 3 lakhs, 30,000. So 36 lakhs 30,000. If you don't pay at the end of second year, you pay at the end of third year, the value goes to 39 lakhs. If you don't pay it at the end of third year, fourth year, and it becomes 43,92,000. And at an end of 5 year, this figure was shot to 48,31,000. Okay. So answer is so this is total repayment. So total repayment in 5 years is it becomes 40. Same thing is mentioned by in a formula. 30 lakhs into 1 plus 10 by 100, that 0.1, 10% to the raise of 5. So that becomes again the same value. We have to get the same value, 48 lakhs or 31,000, which means the monthly payment works out to divided by 5 and 5 years and 12 months. It becomes 80,525 rupees. Okay, so this is clear. I hope both the calculations are understood by you. Is it understood?
Yes, sir. Understood, sir.
Okay. So let us go to the let's go further. Okay. We have studied when we studied the chapter 10 in book 1, we studied some of the financial techniques. But I will we just recapitulate. Actually, in my opinion, the chapter 10 of book 1 is far more elaborate than this chapter 4 of book 10. But and most of that is repetition. Same examples are given over here, to explain the various terms, various definitions, various items. So anyway, that is, repetition is good for us. Since the examples are same, once you read a chapter 10, it becomes much easier for you to read the chapter. First book is seventh chapter, fourth book is 10th chapter. So it becomes very easy to understand 10th chapter in book 4. Okay, so payback period, simple payback period is you make an investment of say X rupees. How much time is required for investment to be returned, considering all the expenses also. That means whatever amount of saving you are going to get by installing at energy efficiency project. So how many years you should, in how many years you will get the total savings will be equal to, yeah, the total that is spent. So in how many years you are able to get that much money that you have invested. So that is the payback period. After that, that period is over, all that money you are going to get is the real savings that you are going to get. Okay. Till such time you are recouping the investment that you have made. Okay, so this concept we have all understood earlier. Now here there is an example given over here. A small example is given over here. So this will make it little more clear. So this example 10.4 says that a new small cogeneration plant is to be installed to reduce the company's annual energy bill by rupees 4,80,000. Okay, annually. If the capital cost of the boilers is 22 lakhs 20,000 and the annual maintenance cost is rupees 40,000, 42,000 per year, what is the payback period? So we can work out backwards, and which means that payback period is equal to 22 lakhs is the total cost of the installation. What is the definition of payback period? The investment or the fixed cost divided by the savings in rupees. So here the investment, that means the new boiler installation cost is 22 lakhs, 20,000 rupees. And the annual energy that we will be saving is 4,82,000 rupees. Energy means energy cost that you are going to save. And so if you reduce from the annual if you from the annual saving, you reduce the operating cost of 42,000 rupees, which means that it is about 4,60,44,000 rupees. 4,40,000 rupees becomes a net savings. So therefore, total cost divided by net saving of 1 year. Okay, so therefore what you get here is 22,20,000 by annual savings per year, which gives you the total number of years payback period. So which works out to 5 years. I hope it is clear.
Yes, sir.
Okay. Then there are two. One method which it is not mentioned over here is the ROI, return on investment, which is not mentioned over here because there is nothing much to calculate. So it is very simple that you invest, let's say, 1 lakh rupees in particular installment, and the amount of energy that you save here is let's say X amount of energy, let's say 50,000 kWh, and sorry, for not for say 450 500 kilowatt into multiplied by the you multiply by the uh, number of years. Okay, so that will give you how much is the saving. Okay, sorry, divided by the investment. So 1 lakh rupees is the investment. You are getting, let's say, 25,000 rupees, 25,000 rupees saving. That means 25,000 rupees is saving divided by 1 lakh, which gives you a figure of 0.25 or 25%. So ROI is 25%. You understood?
Yes, sir. 4 years.
Yeah, I mean, ROI is not 4 years. Again, I will repeat. If you invest 1 lakh rupees in an equipment and get, saving worth rupees 25,000, savings worth 25,000, okay, that means 5,000. Uh, uh, so 25,000, 500 units into 5 rupees may be the rate. 25,000 is saving in rupees. So the internal rate, ROI, return on investment, is 25,000 by 1 lakh rupees, that is 25%. Is that clear?
Yes, sir. Yes, sir.
Yes, sir.
So, in return on investment, there is no concept of years. Payback period, the concept of years is to the extent that how many years you take to get that money back. Whereas annually, what percentage of savings you get out of the investment made. Okay. So let's go to the third one, which is net present value. And the fourth one is IRR. So first go to the net present value. So what we discussed in the chapter 7, book 1, was that the value of money, it changes over a period of time. Okay. If we invest 1 lakh rupees, we get, and the interest rate, let's say it's 10%, what we will get next year is 1,10,000 rupees. You will get it back if you invest for 1 year. Okay. Whereas if you take a loan of late 1 lakh, and after 1 year you have to pay interest of 10 years. So the total of amount of money that you have is 1,10,000 rupees. What it means is that the money that you get, say 10,000 rupees in the after 1 year, today, today that 1,10,000 which which is the value of money of one after 1 year. Today it is 1 lakh, or vice versa. If the future value after 1 year is 1 lakh rupees, what you have to invest is 90 rupees 90.9. 1 divided by 100 divided by 99, 110. Okay, so that is the calculation. Okay, so taking that concept that value of money changes over a period of time. So if you invest some money, you keep on getting, let us say, 10,000 rupees as a saving every year. 7,000 rupees if we get after 1 year is what is the total saving as of today? So present value of that 10,000 rupees which you get after 1 year, what is its value today? 10,000 rupees after when you got in the next uh, second year, what is the value of that 20,000 rupees, 10,000 rupees today? That is the net present value. Okay. So we have seen that there is a series which was also mentioned over there. So what we will just see this example. We will go through the example to make it very clear. So the example is 10.4. Instead of installing a new generating system, the company invested rupees 22 lakh 10,000 in a bank. And annual interest rate, let's say it will get is 800 rupees. The value of sum at the end of first year is 22 lakhs 22,000 plus 22 lakhs 20,000, 8% of that. That means the total value of sum that you will be getting is 23 lakhs 97,600. So therefore, this 23 lakhs 97,600 after 1 year is equal to 22 lakhs 20,000 today. That is how you calculate it for every year. If you are going to invest for 2, 3, 4, 5 years, that you will get the answer. Now here, let's see the example further. In value of sum after first year is we have worked out that 22,000, 20 lakhs 20,000, which is mentioned over here, plus 8% of 22 lakhs 20,000. The total becomes 23 lakhs 97,000. Okay, at the end of second year, you are getting 23 lakhs 97,600 plus 8% of this figure. So this works out to 25 lakhs 89,400. Okay. So what does it mean? It will this is called as the future value of money. That means the 22 lakhs 20,000 is the future value after 1 year is 23 lakhs 97,000. After 2 years, the 22 lakhs 20,000 becomes 25 lakhs 89,000. So that is the future value of money. Okay. So this is the future value of money. Now, if we have to calculate, let's say for 5 years, there is a simple equation. This is the present cost, 22 lakh, or investment, 22 lakhs 20,000, and it is to be calculated over 5 years, and the interest rate is 8%. So the factor is 1 plus 0.08, now whole to the power 5. So the total value of 22 lakhs 20,000 after 5 years becomes 32 lakhs 61,908.40. This is the figure which is worked out, which means that after 5 years, the interest that on that investment is 32 lakhs 61,908 minus the original amount 22 lakhs. That means you have paid amount of this 32,61,908 minus 22,000 is equal to 10,000. 10 lakhs 41,908. This minus this is the amount of interest that is paid in matter of 5 years. Okay. So, if, so the investment that you made in that particular instrument or in that particular equipment, the value will rise to 22 lakhs 20 from 22 lakhs 20,000 to 32 lakhs 61,908. Okay. So future value is 5 years is 32 lakhs. Present value is 22 lakhs 20,000 rupees. Okay. So this is the concept of present value and future value. Okay. Both go together. One is the present value, one is the future value. Future value will be more, present value will be less. Okay. So hope you understood NPV.
Yes, sir.
Yes, sir. Yes.
Okay, because you may have to do some calculation, no, in your paper. You may have to answer all these questions. Now, these equations are given over here. Instead of, as I mentioned, in financial, calculation, you don't use the word interest always when you make an investment. What happens is that you get some saving. Okay, so what you actually get is that you don't get money when you invest in an energy saving project and you get some saving. That saving means saving in the cost of this that energy that you have saved, but you are not really getting interest. So therefore, that factor interest, which is called as the interest when you invest money or when you borrow money, that factor is called discount factor. Okay, so that discount factor it's it is to be kept in mind. Okay, so instead of interest, we are going to call it as a discount factor. Okay, so let's go to the next. Now, in order to make the calculations easy, we have understood that present, this equation, this is the final value. In fact, I would like to show you. I'll open this book 1. Okay. Now, net present value, I'll just like to show you. This was the calculation done over there. Now, here it is mentioned. So here the question is future value is equal to NPV plus 1 to the power I is the discount factor, okay, or discount rate to the power n is number of years, or vice versa. Net present value is equal to final value divided by 1 plus I to the power n. This is how it is calculated, and the series is given like this. This is the investment that you make, CF0 1 plus K. K is the discount rate to the power 0 in the first year, because when you make an investment, there is no time, so it is 0. After first year, CF, whatever the saving you get, divided by 1 plus K is interest, discount factor to the power 1. Second year, it is to the power 2, and so on. And you add on. Net present value is the addition of all these quantities. So if the sum of all these quantities, that means sum of the values are at the end of first year, second year, third year, fourth year, etc. Okay, so that is how it gets added. The example given here is this one. It is written over here. I'll explain this example so that it will be clear to you. There are two projects. One project is project 1, second is a project 2. The investment for both is 30,000 rupees. In the first, for the first project, the savings are for the next 10 years, savings are 6,000 rupees constant. Okay, that means the total savings in 10 years is 6,000 into 10 times 60,000. Whereas for the second project, the savings are variable. First year it is 6,600, second year is also the same, third and fourth year 6,300, fifth and sixth is 6,000, seventh and eighth is 5,700, eighth is 5,400. Yeah. So total saving year also becomes 60,000. So in that sense, you invest 30,000 for more projects, you get the same amount of 60,000 rupees after 10 years. So theoretically, both are same, but they are not. Now why they are not? Let us calculate what is the present value of this 6,600 today, 6,600 after 2 years, 6,000 after 3 years, and similarly for the 6,600 today, 6,600 after 2 years, 6,300 after 3 years, and so on. So what is the value of these savings in as the present value? This is worked out here like this. So 30,000 is investment, this is minus. So actually this will be 1. Then 6,000, this is for the first project, 6,000 by 1 plus 0.08. 8% is the discount interest rate, discount factor, which is given here. So 60,000, 6,000 by 1.08. Second year, 1 plus 0.08 square, and so on and so forth, till 10th year. So this works out to 10,254. So the net present value is 10,254. What it means that when you have invested 30,000 rupees, okay, and you have got the savings of 6,000 rupees for 10 years, okay, if you work out this in terms of the today's value, actually you are going to get 60,000 rupees. So you might say that I have got 30,000 rupees in 10 years. Okay. But actually what it means today is the sum of these calculations, which works out to 10,254. So it means you are getting ineffective today on today's value of money. You are getting 10,250 rupees more. Not this 60 minus 30. This is the total excess you are getting because 30,000 you pay and 30,000 is the saving. But instead of that 30,000 saving, you receive in 10 years, it means that you are getting 10,254. Okay, is in 10 years. This is as of money of today's value. Similarly, for the second project, the net present value, if you do this calculation similar way, 6,600 is first year 1.08, 6,600, 1.08 square, 6,300, 1.08 to the cube. This works out to 10,867. So the net present value is 10,667. So this is the example given in book 1, chapter 7. Okay. Now let me turn to book 4. The same value same values are taken over here. So same project example is given over here. Why I'm showed the earlier calculation? Because here calculations are given in a different way. Okay. It is easier to understand what is given in mentioned in chapter 1. Okay. What is mentioned here is that they have given a table. They have given that for different discount rates, 2%, 4%, 6%, 8%, 16%, etc. When you want to calculate the net present value, you have to work out the savings by this factor. So compound discount factor. It is not a discount rate. Discount rate remains the same, 8%. But the discount factor to work out that particular NPV, it will be, this is going over here. Okay. So for 10 years, these factors are worked out. So this table is given here. This is easy for you. Just take that for the first year, saving multiplied by this factor. Second year, saving multiplied by this factor. And you go on adding if the interest rate is 2%. Now here the interest rate is 8%. So your first year it is obviously, and investment, though there is no question. After 1 year, factor is 926. So savings of 6,000 rupees or 6,600 in the project 2 multiplied by this is the NPV, saving in NPV this year. So the same calculations are given over here. You can see there's the same figures here. Okay. Now what is gives is they are given a table. Okay. So for the discount factors of 8%, same what is it, 10 years, these figures are taken in this particular table, same value, they are not different. In case of project 1, it is the investment and the saving. You have to multiply this by this factor. So this multiplication for project 1 it gives you again the same answer, 30,000 minus, plus you add this 3, this will be 40,254. Then the net is 10,254. Similarly here, similar calculation. The net here is net present value is 10,086, 87. Okay. So I think both the examples are same. The method in which these are given is different. You can either work out, every time, that factor 1 by 1 plus 0.08 to the power 1, 1 by 1 plus 1.08 to the power 2, 1 by 1 plus 0.08 to the power 3, and so on. But easy is they have given the table where this 1 by that quantity is mentioned here. So becomes very easy. You multiply the saving by this, you get the total NPV. Similarly here also. So therefore you can very quickly complete the calculation. You don't have to use much time, and you get the answer. Okay. So both example is same, answers are same. The method is different, and this one is easier. Okay. So have you understood this?
Yes, sir. Yes, sir. Understood.
Okay. I will proceed. It's the same thing. There's no change over at all. Explain and is given in different language. Now let's go to the concept of internal rate of return, which also we learned. And the principle here is the internal rate of return is the rate of return at which the NPV becomes 0. That means NPV is equal to 0 if you equate, and the interest that you get it if you work backward is the internal rate of return. Okay, so if you now let us see the same example over here to understand it more. So here the example it is mentioned that the plot projects we given above, the present value after 10 we have calculated at the discount rate of 8%. Now if so which means that okay, NP will tell you that NPV is more here, and 10 to 10 8 6 7 NPV is 8 10 2 5 4. So the common sense tells us that you are going to net value is more here than this. So definitely you are going to get more returns here. So this is a better investment. You should prefer this project and not this project, although total amount of rupees that you are going to get in 10 years is the same. 30,000 rupees both the years, plus 30,000, 60,000 rupees both the year, 30,000 is the investment. But internal rate of return, when you calculate, so that is like the same example is can be taken. But anyway, what they have given a different example, which is also taken in that IRR. So I will also go to that. Now the example is a proposed project requires capital investment of rupees 20,000 rupees, and in 10 years time, sorry, not 6 years time, the savings which are generated are 6,000, 5,500, 5,000, 4,500, 3,000 and 4,000. Okay. Now here, uh, in in case of this one, chapter 1, same example is given over here. Okay, 20,000 investment, same savings 6,500, etc. We have worked out. I mean, last time we had done this exercise, we had worked out, at 8%, the NPV works out to 2,791. You calculate this, if you do this calculation. Okay, and you will see that this factor 0.926 is 1.01 over 1.08. This factor 0.857 is 1 over 1.08 square, and so on. 2,791 is the NPV. If we increase the discount rate to 12%, you are getting 495. That means still you are getting plus. Okay, so actual discount rate when the NPV is 0 has to be lower. Okay, now instead of calculating 13%, 14%, 11%, sorry, 13%, 14%, 15%, you are, so we have increased the discount rate to 16%. So it is has to be, so it is worked out, it works out to minus 15.08. That means the actual discount rate to make this value 0 is more than this. Discount rate is more than this because it's positive. This is negative, so it is less than 16%. So when you work out pro rata basis, it will work out to 12.88%. Okay, these calculations have been done. We are not going to go through that again. Okay, so let me go to this chapter. So here it is also mentioned the same thing. So 8%, 12%, 16%. Only thing is that here they have multiplied by this discount factor. Instead of calculating every time, ready-made discount factors are there. So you can see that the same value of NPV 2,791, 4,959 and minus 1,597, you get it. So if you work on pro rata basis, it will be, 12.93%. There is small difference because these two bigs actually should not be different. Should be 12.93 at both places or 12.88. So anyway, that error is is in the books. So this 12.93% is the IRR. Okay, this is the internal rate of return. That means this is the rate that you really get by investing a particular amount of money for energy saving projects through the savings that you achieve for, say, 5 years, 10 years, whatever it is. Okay, so I hope you understood this calculation.
Yes, sir.
Okay, shall I proceed further?
Yes, yes.
Okay. Now there is another concept term mentioned over here, which was not there in the chapter, in the first book. So it is the profitability index. Okay. What is profitability index? It is defined as the ratio of NPV after a certain period of time over the investment. Okay. That means that is the amount of profit, that is indication of the profitability of that particular investment, that particular project. So project 1, the profitability index is 10,254 by 30,000 rupees is equal to 0.342. Similarly, for the project 2, it is 0.362. Okay, so these are the answer. And the factors affecting the analysis, we have studied in book 1. We are not going to study it further, over there. Similarly, risk analysis and some other aspect we are not going to study over here. Now let us see the example to understand, these things more. Here, let's see, go through the example 10.9. Okay. So what it says, it is proposed to install a heat recovery system in a factory, and the capital cost of installation is 20,000 rupees. After 5 years of time, their salvage value, that means the value of that particular equipment after 5 years is 1,500 after 5 years. So they say you calculate what is the net present value, considering 5 years period and discount rate of 8%. So, and the savings are first year 7,000, 6,000, second year, third year 6,000, fourth year 5,000, fifth year 4,000. These are the saving. The investment is 20,000 rupees. Okay. So what they calculate, these are the discount factors. 20,000 rupees the investment, and this savings 7,600 multiplied by this is discount factor. These are the actually saving as of today. So, 7,000 rupees after 1 year. As of today, the saving that value is 6,400. You work out this, calculate this, you get 4,489.5 is the NPV. Okay, by this particular, using only the factors, ready-made factor. So you can use that table to get the answer quickly. Okay, which it means that you are getting 4,489 as the NPV is the total amount of net money you are going to get, after 5 years. But as of today's value. Okay, if we had not here, we have added. You will see that in the fifth year, 1,500 was the salvage value. Okay, so this you added to this savings. You added this one, and what they do is that 5,000 rupees you save in the last year, salvage value is 1,500 in fifth year. So that 1,500 is added to savings of fifth year. So 6,500 multiplied by this factor is 4,428. So the answer is 4,489.50 NPV. Okay. If this was not there, 5,000 would have been multiplied by 0.68. Now that works out to some 3,400, something like that. Okay. So this would have been 3,400, and this value 4,489 would have become 3,464. Okay. So this is the difference it is made by considering a salvage value. Okay. Now it is the choice of that organization to consider the value or not. Because if you are able to sell that equipment and realize money, then that salvage value has a value, has some significance. Otherwise not. Okay. So here it is mentioned that rival value, the same things are given over here. Okay. Now, so you understood this? So here the only question is salvage value is considered, and how to give a treatment consideration to salvage value. You understood?
Yes, sir.
Okay. Now there is an additional element. What is that? We all know, all of us know that there is an inflation. Okay, that means 1 rupee, what you spend today and what you are able to buy today after 1 year, because the cost of that particular product has gone up. So you may have to spend 5%, 10%, whatever is the inflation. To that extent, you have to pay more. Okay, so this concept is known to all of us, that because of the inflation, the cost of the goods investment rises. Okay, so whatever amount of you invest today, and you are getting some savings, but at the same time, there is an inflation. That means actual money, actual realization is less, to the extent of what if you get 10,000 next year, there is inflation already. So you have to also take that inflation into account to know the actual net value that you are getting. So, so what it means that so we have to really calculate what is the real value. Okay. So the example given here is I'll read this. Recalculate the net present value. If the energy recovery scheme is in 10.9, 10.9 is this one, this one. So 4489 is investment is rupees 20,000. These are the saving. NPV is 4489. If we want the same thing, if the inflation rate we want to consider inflation of 5%, then how it works out? Let us see. So here the table is very clear. This is year 1, 2, 3, 4, 5. Investment 20,000 minus. Okay, so this become minus. Okay. First year 7,000, saving 6,000, second year 3,000, 6,000, fourth 5,000, 5,000. Okay. Now the inflation factor is also, it is also same way. Like the discount factor, this also is, it goes into the denominator. That means after 1 year, that value goes down by 5%. That means point discount factor is 5%. You work out this for fifth year, you take these factors and this you work out, to the 6,664. What is 6,664? Is is this value? Okay, is this value multiplied by so this is only if only inflation was there. This inflation was there. This you would have got it back. Okay, so first year, second year, third, fourth year. So these figure out what out this multiplied by this factor, this 6,642, 6,664, 5,442, etc., etc., and the total works out to. So which means that this real value is actually 5%. This is the real value after 1 year, considering inflation only. But there is a discount factor is 8%. Discount factor is the saving, and inflation is the actually negative. So 8 minus 5. 5 is the actual real discount factor that you are applying. This is the saving actually you are getting. Okay. So out of this figure worked out after inflation. Okay, that means 7,500 after 1 year is equal to this much. Now there are only effectively 3% only you are going to get that discount factor. So this becomes you have to multiply it by a factor for 3%. You will see that you remember there was a table. From the table you take factors for 3% instead of 8%, and you get these figures. So this multiplied by this is equal to 6,470. 5,442 multiplied by 0.943 is 5,131. And so this works out to NPV works out to 4,397. What it really means is if you consider only this, don't consider the inflation, the savings that you are going to achieve, the near real value, net value is 4,489. Okay, but if you also consider the inflation, taken that into account, it works out that the NPV, that actual return you are going to get, is 4,397.88. Okay, which means that actual value has gone down to some extent because of the recession. Okay, so because of the inflation. So this way the calculations have to be done. Okay, so now let us see. There are two examples given over here. we will see them in more detail. They tell us more about how to do the calculation. Okay, so these two examples are actually given as a guide for you to do the calculation. How you do the calculation? Okay, so there are two examples given. Let us go through that those two and try to understand how the calculations will be there. So let's first see the first example. There are two energy saving projects. In the first project, the investment is 1 lakh rupees, 50,000 rupees, and the net annual savings is 50,000 rupees for 5 years. Salvage value at the end of 5 years is nil. There is no salvage value. Okay, so we can what we it asks you to calculate is net present value for discount rate of 9%. I am not reading this purposefully because let us see that example and calculation later on. But these are the things to be worked out for both. So for first one, net present value of project with discount factor 9%, profitability index you work out, also IRR you work out for the workout. Okay, so here they have solved the example. NPV in the first case is 1,50,000, which is the investment. Savings is 50,000 rupees, constant for 5 years. It is mentioned for 50,000 for 5 years. 5 years is the period given. Salvage value is 5,000 rupees. Okay. So salvage value is also given as 5,000 rupees. So in first case, salvage value is not given, is zero, in first zero. So therefore there is no addition, no deletion here. So you work out the NPV is equal to 44483. Okay. For the project 2, you do the similar calculation, for, in the second one, 550,000 rupees is a saving, 1,50,000 investment. But for the first 2 years, the saving is 60,000 rupees, 50,000 rupees. And for the next years, it is 60,000 rupees. And salvage value after 5 years is 10 years. Okay, the first thing is that you have to do this calculation for 5 years, and the salvage value of is 10,000. You have to take that into account in the fifth year. Okay, and the savings are different. So if you calculate the NPV, I will read this: 1,50,000 investment, 50,000 investment in first year, 9% is the discount factor, so 1.05, by 1.09. Okay. Second is 50,000 by 1.09 square up to 5. Okay. Second is the 60,000 third year. 1.09 is the third year to the power 3. Savings is fourth year 6,000, 1.09 to the power 4. Fifth year is 60,000, 1 to the 0.09, because this discount rate is same to the 5. And plus add 10,000 rupees, and you apply the same factor because salvage value is of 10,000 in the fifth year. So today it is 1.09 to the power 5, like this one. So if the total works out to 72,287. Okay, so NPV for project 1 is 44,483. For 2 it is 72,287. Okay. Profitability index is NPV by investment 44483 by 150,000 is 0.297. For the project 2, this is NPV is 72,287 by 150,000, so 0.481. Obviously, this is much higher. And IRR, if you work out for both, the calculations are not mentioned here. They have to be done in a similar fashion. So IRR works out to 19.856%, and for project 1, and IRR works out to 25.07% for project 2. Okay, so which is very clear. Project 1 is better because NPV is better. Project 2 is better. NPV is 72,000 instead of 44,000. Profitability index is also 0.481 instead of 2.297. And IRR also is 19.67% for the project 1. For 2, it is 25%. So in all respects, project 2 is all better because all three indices answers we get are positive more for project 2. Okay. So this is now let's go to second example, which is also easy. So there is a VFD to be retrofitted with an investment of 2,55,000 rupees. VFD will be installed on a motor to reduce its energy consumption. 2,55,000 rupees is the investment, and annual savings you are expecting is 58,000 rupees. Okay. The NPV of the project over 6-year period, at 8% interest is the figure given is for 8 years is 13,134. Okay, NPV of this particular, if you work out, it will be 13,184. Okay, the NPV of the project over 6-year period, if the interest or discount rate was 10%, it will work out to minus 2468. Okay, so the answer that is required is calculate the exact discount rate for NPV is equal to 0, or what is the internal rate of return. This is what it is. So this work is worked out like this. So positive and negative NPVs are closer to positive. Here it is calculated is 13,134, and 10 years 10% discount is 24,668, which is mentioned over here. This is minus. Okay, so you remember this is minus. This is plus 13,134. This is minus this one. That means it is closer to this, but on the lower side of the investment. Okay, so it can be extrapolated. They have calculated it, using the same extrapolation, and they find that exact discount rate is 9.68%, or in other words, IRR is 9.68%. Okay. So with these two examples, have you understood?
Yes, sir.
Mr. Ambarkar?
Yes, sir. Yes.
Satyanarayana?
Yes, sir. Yes, sir. One more reading.
Okay. So all the examples which have been solved in this particular chapter, they are not, they are nothing new. The concepts are same. What we had studied in chapter 7 of book 1, financial analysis. These are only examples given here, because in the fourth paper, they will not ask you, they may ask you some theoretical question, but they will rather ask you to solve some examples. So we have seen these few examples for each of them, how to calculate payback period, how to calculate net present value, how to calculate then the profitability ratio, to how to calculate net internal rate of return. Okay, so with this we close the chapter reading, and let us go to the questions and answer session. Is that all right? You understood the chapter?
Yes, sir.
Okay. In my opinion, this is nothing but a common sense. Okay. Financial analysis management is nothing. There is no concept. Once you know what is NPV, you just go on calculating it. It is mechanical calculation. You only have to keep in mind what is the investment value, what is the saving, how many years, whether it is uniform, whether it is varying. Okay, what is the salvage value, and calculate IRR, calculate ROI, calculate a simple payback period, and so on. So it's only the calculations which differ. There is no concept, there is no change. So unlike other chapters, there is no much concept mentioned in new concept mentioned except the profitability ratio. There is nothing new in this chapter. So we will close with this and go to the question. Shall I?
Yes, sir.
Okay. Uh, Now we go to the define ROI.
Return on investment.
Yeah, yeah, define. ROI is only you explain the full form. What is? So answer if you say ROI is rate of return on investment, you will not get marks.
Right.
Saving divided by capital investment.
Ah, yes, yes. As a percent expressed as a percentage.
Yeah, percentage in ROI, right?
Yeah.
Multiplied by 100. It will
ROI
come.
will be in percentage.
Yeah.
Okay. So saving multiplied by capital investment in rupees, and this multiplied by 100 is the percentage return, ROI. Okay, go to the next one. S2, explain why a project with a higher ROI is not necessarily more attractive than a project with lower ROI. Can you answer? Yes, Mr. Satyanarayana.
Yeah.
Mr. Deshpande.
If IRI is better.
No, they say not necessary. I mean, what we
That
have studied in the first chapter, first book, chapter 7, and also here that IRR should be higher. Let me
Yes, sir.
see if I can see this. See this statement. Let me go to chapter 1.
Chapter 1, it is not given, sir, I think.
Yeah, this is it.
Uh,
This is IRR. I am just looking at that particular statement. Okay. Here the answer is given is, otherwise the answer is, we are always saying that net present value, if it is higher, that is better. IRR is higher, that is better. But here it is mentioned, the internal rate of return cannot distinguish between lending and borrowing rates. Okay, lending and borrowing. Hence, higher return cannot be necessarily taken as a desirable feature. This is the answer to this question.
okay.
This is the answer to this question. This is the answer to this question. You get me?
Yes, sir.
Okay.
Yes.
This is not given in this chapter. So I showed you the answer in the, because all answers can be found somewhere in that particular chapter. Okay. The questions and their answer will be from this particular chapter. In this case, there is no, in this book 4, chapter 10, this is not mentioned. So I have shown this answer in book 1. Because book 1 also deals with the same topics. Is it clear?
Yes, sir. Yes, sir.
Okay. Now this is again very simple. S3, you are investing rupees 100 in a bank. The bank gives 10% interest for, per year. So for 2 years, what is the present value and what is the future value?
100 will become 1, 2.
Tell me the answers in. You know, 100 rupees is the present value.
Yes, sir.
Okay. Value after 2 years. If V is equal to NPV multiplied by 1 plus 1 point what K to the power 2 in this particular case 2 years, or if it is 5 years, it is to the power 5. That is the future value.
Future value will be 121, sir.
121, which is
Future value.
because it is 2 years, we can very simply calculate in your mind. You don't need anything. You don't need a calculator. You don't need anything. But it was 5 years, you will have to calculate, right? So this is the
Yes.
future value is of 100 rupees in 2 years is 121. What is the NPV?
Present value.
NPV 121. You get 10 rupees first year, second year 10 rupees. But whereas 121 you get, considering the uh, compound interest. So what is NPV? Calculate.
100.
What do you? How will you calculate?
10%, sir. Divided by 1
No.
point. That will be
See.
82.64, sir.
Huh?
82.64 paisa. 82 rupees 64.
How? How do you calculate?
So 100 by 1.1, sir.
Yeah. See, minus 100. 100 by
Minus
100 by
1.1.
1.1. That is equal to 90.
90
Okay.
years. That will become 1.1.
And second year it is 100 by
90.9.
by 1 point.
90.9 by 1.1.
100 by 121.
Okay.
1.1 square.
1.21.
1.21.
Yes, sir.
So that 1 by 1.21 is 83. So 1
82.6.
by, so 90 plus 83, 91 plus 83 is equal to how much? 174 minus 100. So how much it is? 74. How did you calculate 82?
No, sir, 10% is the discount
Yeah.
value. No, sir.
So the equation is, you write down, first is minus 100. Okay.
Minus 100.
Second is 100 by 1.1 square. So 100 by
1.1.
1.1, this is 90. Third term will be 100 by
1.21.
1.1, 2.
21.
1.1 square, 121. So
120.
1 by 121 is 83. So 91 plus 83 is equal to 174. So NPV is equal to 174 minus 100, it is 74.
So
Am I right,
74, suppose,
Satyanarayana?
sir, 74 we back calculate, it will become 100, sir. Then it should become.
No. How you calculated? Same thing. Okay, you can, what you can do is, I think all three of you, what we calculated just now is the 74 NPV.
74.
Satyanarayana says 84, 82.
82.
In your home, you calculate and confirm yourself. Okay, whether it is 82 or 74. Because, at least for what I would say, you write down the steps.
Yes, sir.
Okay, because steps,
Seven-
if you write down, you won't go wrong. Okay, calculations, you will have a calculator which can do. But steps you must write down correctly. And then you will get marks. Otherwise, wrong answer, 0. Write down some steps, they make you some half mark, at least.
Yeah.
Okay, go to the fourth question. What do you understand by term present value? So you
Present
got
value is the
to,
discounted value.
so you have to read this. Present value of money is whatever amount of you are going to get in future, converted into today's value, that and a total of all years is the present value. What is the advantage of simple payback method? What is the advantage? One or two? Tell me.
Easily can be calculated, sir.
Yeah,
And this-
easily. Second, it quickly tells you. We are all geared up to that, no? Our mentality. Your payback period is 2 years, 3 years, 4 years. Immediately we know, okay, good. 1 year payback period is very good. 10 years payback, too much. So it immediately helps you taking a decision. If it is 3 years, 2 years, 4 years, you can take a decision. Some people will say 3 years, I will accept it. Some people will say 3 years, no. It depends. Okay. 3 years may not be questionable, but if it is 5 years or 7 years, and then everyone is going to think. Some people may, they will say after saying, किसने देखा है 7 साल के बाद क्या होगा, so why invest? Okay, that is that. So you can make a mental immediate decision. So what is the main drawback of simple payback?
Yeah, it is not considering the time value of the money.
Correct, correct. Which means that it only says that you are getting this much money back in 3 years, 4 years. Okay, but that value is reducing. That is taken care of by this. And second thing is, what is the second major advantage? What are drawback? It cannot differentiate between a project which gives you more overall savings. Okay, in the initial year, and in the example that we saw, okay, let me see if I can quickly go through again. Okay, let me go through this. So this will tell you very quickly. Yes, this is the drawback. This is first 3 years you are getting 1 lakh rupee back. Payback period is 3 years. 1 lakh is the investment. 50, 30, 20, 1 lakh. 3 years you get 1 lakh rupees back. Payback period is 3 years. Whereas this one, 20, 20, 20, 20 is 40. First 3 years it gets you 60,000 rupees. So you are going to say, and fourth year 40,000. So this is 1 lakh, which means this payback period is 4 years. So you will say this project is good, but this is more, this is more, this is more. Here there is no saving anything. So payback period calculation does not give you this picture. You get me? You understand? That is the disadvantage. Okay, what is the profitability index?
Profitability.
Hmm? NPV by investment.
Saving capital investment.
Yeah, calculate NPV by investment. Profitability index means how much is the profit you are getting in terms of the real value. Go to example S8, which is simple again. Cost of heat exchange is 1 lakh rupees. Calculate simple payback period considering annual saving potential of 60,000 and operating cost of 15,000. You can do this calculation orally. How much is it? You tell me the equation.
That is so that is a investment cost plus operating cost divided by potential saving.
No. Investment is negative. Investment negative. Operating cost deducted from the saving. So numerator
Okay.
is investment 1 lakh rupees.
Oh, right. It has to
And
be minus.
denominator will be
Yeah,
the
60
savings
minus 15.
60,000 rupees minus the operating cost. So the net saving is 60 minus 15, 45,000 rupees. So the savable payback period is 1 lakh by 45,000 rupees. That means 2.2 years approximately. You get me, Mr. Ambedkar?
Yes, sir. Yes. Instead of
Okay.
adding it, we should
Yeah. You
minus.
have to calculate. See, as simple. You remember the simple payback period is the investment or the net savings net.
Yeah, net saving. Yes, we have to calculate the net saving.
So go to then what is the object of carrying out sensitive analysis? This is your descriptive question. You have to go to first chapter to know this answer. Sensitivity analysis to be carried out to find out how good the investment is in simple terms, but you have to correctly answer from the chapter 1. Okay, go to the next, go to the long question. What are the factors affecting financial analysis while computing NPV and IRR? Okay, I'll answer this very simple. One is that what is the number of years, for which and it is to be carried out, how many years this analysis is to be done. Second is the what is the discount factor. Okay, so that is another thing which you have to take into account. Okay, and then you go read that description in this chapter as well as other chapter and answer it. Let's go to the example, which is again simple. It is proposed to install heat recording system with a cost of 20,000 rupees. Savings is 5,000 rupees per annum annually. Discount rate is 8%. Calculate NPV for 5 years. I think we missed one. Calculate simple payback period of a boiler. 75 rupees is the cost, purchase cost. 5 lakhs rupees is the average operating maintenance cost, and it will save 30,000 rupees per annum. So you can do this orally.
Yeah, 75 divided by 30 minus 5, 25, so 3 years.
Yeah, correct. Yeah. So answer is 3 years. Now let's go to the L2. You have to write down, since I think we have only 5 minutes left, I'll just tell you the steps involved. 20,000 is the investment. So the first term is minus 20,000 rupees by 1 plus k to the power 0. That means 20,000 rupees by 1 plus by 1. This is 20,000 minus 20,000. For NPV, we have to calculate. First term is 5,000 rupees the saving divided by 1 plus 0.08 to the power 1. 1.08 to the power 1. Since it is to be done for 5 years, 1 by 1.08 plus 1.1 1.08 to the power 2 plus 1.08 to the power 3 plus 1.08 to the power 4 plus 1 by 108 to the power 5. If you calculate the totally, if you calculate, you will be able to get the answer 5,000 rupees, or you may multiply by the discount factor, because the book is open book. So you can open that table. Okay, you can open the table, see what is the factor, and immediately take that factor. You know, one, you know, sorry, I mentioned 1 by, but it is not 5,000 rupees divided by 1.08, 5,000 by 1.08 square, 5,000 by this. So you can use that instead of 1 by 1.08 itself, you can use the factors from the table, calculate, and then answer will be available. So the answer is minus 35. If you work out, go home and you'll find out this is the answer.
Minus
Now let's go
35.
to the next one. Oh, this is slightly involved. At least the example is more elaborate, but calculations remain the same. Okay. Now this is a waste heat recording system. Its cost is so investment is 6,50,000 rupees. Okay. It is life is 6 years. N is equal to 6. Salvage value is 1 lakh rupees after 6 years. You have to keep in mind. System will reduce energy cost by 2 lakhs rupees per year. Okay. Uh, this is. But it is mentioned here. However, the plant will be operating partially at first 3 years, where the savings are going to be only 70% of the full saving. That means 70% of 2 lakhs rupees. Okay, is for the first 3 years, and from the third year, full savings of 2 lakhs rupees. Okay, this is one. So this is you have to keep this in mind. New system will entail maintenance cost of 10,000 rupees per year for first 3 years. Okay, and 12,000 rupees for the next 3 years. So the equations will be. We don't have time to write down, nor can I show it to you. But I will tell you only the step. What we need to calculate is NPV and also the profitability index. So in effect, it is the example to calculate NPV and profitability index, NPV by investment. So it is basically calculating NPV. Now it is the same equation, same methodology. I will only tell you where is the hitch. Hitch is first is investment is 6,50,000 is minus 6,50,000 rupees. Okay, understood? Minus. First term of NPV is equal to plus, because we have to do this calculation for 6 years. So in the first year, the term is saving is 1,40,000 rupees. Okay, and 10,000 rupees is the maintenance cost. That means the saving is 1,40,000 rupees minus 10,000. So the net saving is 1,30,000 rupees. Okay, divided by 1.0. What is it? Yeah, discount rate is 9. So 1,30,000 by 1.09. Have you understood this?
One,
How is it?
1,30,000 means how fast? 1 lakh.
1,40,000 minus 10,000.
10,000.
That is the
Yes.
saving is 1,30,000. Discount factor is 9%. So first year is divided by 1.09. Okay. Now go to the second. Also here also profit savings is 70%.
1,50,000.
10,000 rupees is maintenance for 10 years. So 130 is the net saving divided by 1.09%.
Square.
1.09 square. You get me?
Yes, sir.
Okay. Now go to the third one. In third one, the saving is 140. Saving is 2 lakhs rupees minus 188. Minus this cost, not 10,000. That means this is 1,88,000. 2 lakhs minus 188,000, 12,000. 1 lakh 8, saving is 1,88,000 divided by 1.09 to the power 3. Am I right?
Yes, sir, 1.09.
Yeah. And second year, fourth year and fifth year, it is, thank you. That's what I read here. Sorry. So third, fourth and fifth year, it's the same thing. Except a 1.09 to the power 4, 1.09 to the power 5 is the answer. So if you calculate the whole thing, you will come to a figure of, the value which I have worked out. You can work out there is minus 106,223.
Minus 106,223.
106,223. Which is Satyanarayana you worked out.
Sir.
Is it same?
No, we have to work
Ah.
out, sir.
1 lakh 106,223. Am I right?
Sir.
Yeah. So I worked out and Satyanarayana also worked out because he has solved that example earlier. So this is the answer. So therefore, profitability index is 1,106,223 by 6,50,000, which means it is 0.16342. Okay.
Okay.
So
How much is the answer? Sir? The answer?
answer is 0.1632. 16342.
1,163.
Yeah, it is
1,6.
1 lakh 106,223 by 6,50,000. So
Okay.
the in all the if what you have to really do is calculate simple payback period investment over the net savings annually, IOR, the annual savings or divided by the capital investment. NPV is equal to FV is equal to 1 plus the NPV to the power 1 point K to the power 1. If it is with second year, 2, 3, 4, same. If it is IRR, you have to calculate NPV equate to 0, and you have to do iteration. That means you go on changing the figure of discount rate, calculate a rate at which the NPV becomes 0, and that becomes the IRR. Okay, so these are the calculation. Normally, they will vary the description in the example, but calculations will remain more or less the same. Okay,
Any
so
question, sir, in the exam?
yeah, so
This chapter.
actually, so you don't have to really worry about this financial analysis or financial management chapters. There are simple concepts. There are simple calculation, not very involved like any like other
Yes, sir.
thermal or something like that. Right? So
Yes, sir.
we close here. We close here. I will just check.
Yes, sir.
Chavan sir is yet to join. I would suggest if you want to take a break, please. I'll do one. First of all, I will stop sharing. I will stop recording. Stop sharing. Stop recording.